responding to this somehow. At least I was so busy. So let's quickly look at it. So the question says, hydrogen sulfide is a poisonous gas, whatever. The reaction for the formation. So it's a reaction for the formation. So that's very important. It means what they gave us is standard heat of formation. That's what we have in the question here. So, and it says use Hess Law to obtain the enthalpy change for this reaction for the following enthalpy changes, from the following enthalpy changes. So, if you look at these enthalpy changes, you will see that hydrogen sulfide react with oxygen. That is enthalpy changes of combustion. Although there are some mistake in their question, that's the problem with this JUPEB something. So all these values, they are supposed to be negative values because they are enthalpy changes of combustion, and combustion is an exothermic reaction, if you remember. So all these are supposed to be minus, 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 and minus. So I don't know how they are going to do when the students are answering this kind of question in the exam. So because it is combustion, reaction with oxygen, this is combustion, reaction with oxygen, this is also combustion. So let's write this given equation, which is H2 plus 1 over 8 S, sorry, not O, S8, Control Z, S8, and then to give H₂S, which is a gas. So we have this. In order to link this up with these standard enthalpies of combustion, we need to add oxygen to both sides of the equation, if you remember. So we're going to add O2 to this, and then we add oxygen to this. So now we can link this with all the study that we have here. So oxygen plus hydrogen, that is this. Let's start from the first one. H₂S plus oxygen is this. H₂S plus oxygen. So H₂S plus oxygen, what does it give us? What's the product? It gives H2O plus SO2. So it's going to be H2O plus SO2. So it means we have the standard heat of combustion of H₂S. It gives H2O plus SO2. Then we look at the second one here. We have H2 plus oxygen, hydrogen plus oxygen, and then we have it at this side. You can see hydrogen and oxygen. So it means, and then whenever hydrogen reacts with oxygen, what is the product? It gives water, and then we have water as part of the product here. So it means you can link this one up here. So whenever hydrogen reacts with oxygen, it gives water. Whenever H₂S reacts with oxygen, it gives water and SO2. So everything is fine. The last one is sulfate. Whenever it reacts with oxygen, it gives SO2. And you can see oxygen plus sulfur gives SO2. So it means we have everything we need. The next is to balance the equation. So if you want to balance the equation, we don't touch what is here already. What they balanced already, we have to leave them alone. So we have 1 over 8 of sulfur times 8. It means only one sulfur. And then, because 1 over 8 times 8, that is 1 sulfur. And hydrogen is 2. Hydrogen is 2 here. You can see there's only 1 sulfur. Oxygen is 2. Oxygen is 2. So this equation is balanced. The horizontal equation is balanced. So let's balance this with respect to what we have down here. What we have down here, hydrogen is H2 and then hydrogen 2 as well. Oxygen is 2 here, but we have, what do we have here? We have 2 as well. So oxygen is, so no, we have 2 here, and then we have 1 here. So it means oxygen is not balanced yet. So oxygen is not balanced yet. We don't need to tamper with what we have down here, because if you put 2 here like this, oxygen becomes 4, and then we put 2 here, it means hydrogen will become 4. Does that right? And then we have to put 2 here, so we start destructing the equation. So what we're supposed to do is to balance the oxygen up here that stays on its own. So we have 3 oxygen down here. So we want to make this one 3 as well. So it means this is going to be 3 over 2. 3 over 2. 3 over 2 times this 2 times 2. So it means it becomes 3 oxygen. So when we put 3 over 2 here, this one can also be 3 over 2. So oxygen is balanced. And then hydrogen is balanced. If you look at sulfur, sulfur is 1 over 8 times 8, that's 1. And if you look at it, it is 1 here as well. If you look at it at this side, it is 1. So everything is balanced. So the next is to, if you remember, this side, it involves 2 equations. It involves this reaction between oxygen and hydrogen. So it means you can say standard heat of combustion of hydrogen gas, and we have oxygen reacting with sulfur, and they give us the value for that here as well. They see sulfur and oxygen, so it means plus standard heat of combustion of sulfur. So these equations down here represent standard heat of combustion of hydrogen and that of sulfur. But the one at the other side here is standard heat of combustion of what? Of hydrogen sulfide. Of hydrogen sulfide. So this is going to be standard heat of combustion of H₂S. Now if you look, remember we want to calculate the horizontal here, that is formation of hydrogen sulfide. That's what we want to calculate. Okay. By calculating that, if you look at the direction of the equation, you will see that, let me remove this. So you will see easily that the equation goes this way. This arrow and this arrow, they follow the same direction. So it means what we have here, which is a standard heat of formation of H₂S. That is what we are calculating, plus heat of combustion of H₂S will give us this heat of combustion of H2 and heat of combustion of sulfur. So we can generate the equation, that is what we are calculating, standard heat of formation of H₂S plus, you can see this arrow down here, it means plus standard, let me say heat of combustion, heat of combustion of H₂S equals the one down here, which is a heat of combustion of hydrogen gas plus heat of combustion of sulfur. So this is what we are calculating. So it means the one we are calculating, heat of formation of H₂S will equal to these two, heat of combustion of hydrogen gas plus, sorry, not this yet. So plus heat of combustion of sulfur minus heat of formation of H₂S. So we just put those values. Is it heat of formation? Sorry, heat of combustion of H₂S, C. So we just plug in those values. So let's plug in those values, and we're going to have what is heat of combustion of hydrogen, and that is minus 242 plus what is the heat of combustion of sulfur, and that is minus 297 minus 297 minus what is the heat of combustion of hydrogen sulfide, this one up here, minus 518. So minus 518 minus 518, that is plus 518. So let me press this. I think I can use this to do the calculation. That will be minus 242 minus 297 plus 518 equals minus 21. So the final answer is minus 21 kilojoule per mole.